Good evening, sir. Sir, good evening, sir.
So you can hear me?
Sir,
Someone respond, Vishakan.
Sir, I can hear you, sir.
Yeah. So let's wait for some time. Let people join. So do the rest of you can see the screen, right?
Sir, yes, sir.
Yeah. So
yes,
there's a
sir.
list of things you should know. So any doubts? Have you seen it or not?
Yes, sir. You screenshot it in class, sir.
Yeah. So any particular doubt? Was let me wait for a few minutes.
The ray diagram, sir. Having some certain doubts in ray diagram.
Okay. So ray diagram, you just have to take those three rays, right?
Yes, sir. Do we have ray diagram for exam?
Ray diagram. Uh, so one ray is the one which is parallel to the principal axis after refraction passes the focus. Okay. In case of concave, it will diverge, but if you project it backwards, it will pass through the focus. This is one particular ray which you will draw. Okay. The second one is okay, the same thing in the reverse direction. Another thing is the one which is passing through the pole will go straight. Okay. Second one. And there is one more which is hitting the pole. Yeah, this is the one. Yeah, with this you can draw all the diagrams because this is the one. So this is the one which is after refraction is passing the focus. This one. Second which is passing to the pole, which will go on straight because this is going straight because the angle of incidence is zero. Uh, when the ray is along the normal, at this point, if you draw a tangent on a normal, this line is along the normal. So since along the normal, the angle of incidence is zero. But once I is zero, sin R will also be zero, refraction will also be zero. So it will go undeflected. So these two rays from the top, which is point A, will meet here to give point A prime. The image A prime corresponds to the object point A. So if it just these two rays is giving me this image. So here also, just with two rays, I'm getting all the images. Ray diagram is not difficult. For example, this one is between the focus and this center of curvature. So here one thing is one which is here's concave, right? So get diverged. If you take a parallel beam, we get diverged. If you project it backwards, you come and meet at the focus. Second one is the one which is passing to the pole. It goes straight. Okay, so these two light rays are meeting here. So two rays from A, which is this one, and this one. So this one it's as if it's the projected one is coming here, and this one is straight, it's coming here. So
Sir,
yeah,
sir, I have a doubt,
yeah,
sir. Question I'm having doubt, sir. Can I share that question to you, sir?
yeah.
Yes, sir. 1 minute, sir.
Yeah. So the ray diagram is not difficult. You just have to, here there are considerably two rays. One is the ray which is parallel to the principal axis. After refraction, it passes through focus. Second one which is passing through the pole, which goes straight. Two lines are enough to intersect to give me a point. So two rays from the top, A will give me intersect at a point at A prime. That'll give me the inverted image.
Yes, sir.
Just a minute.
I have shared one picture in the general
Yeah.
chat group, sir. Can you see it?
Where is the table?
Now it came, sir. Can you see it, sir?
That's coming. It's coming. Wait.
Image, sir. Sir, use, sir. That image they have given, by using that they are asking us to find the focal length of convex lens, sir. They have given many information, sir. How can we find the focal length,
Don't
sir?
need everything. Just one set of U and V will give you the focal length.
How can we find the focal length, sir?
Hold on. Just one set of U and V will give you the focal length.
Sir, so like in that case, yeah, we can see that U and V, that minus 18 and plus 18 are equal. So like we can say that F is equal to V by 2. So F will be 9 centimeters, sir.
Just a minute.
Sir.
So there is a question. They are saying it's a convex lens, and we are given, right. So I'll choose the second data. U is minus 14.
Yes, sir.
So
Yes,
where I
sir.
can find the focal length.
Yes, sir. How, sir? Can you teach me, sir?
I'll come. So if I use the second, uh, this data, second row. Okay, so U is minus 14, right? So if I use the lens
Yes, sir.
1 by U is 1 by V, put 1 by F. So there should be a minus sign here. Because for convex lens, U is negative, right? V and F are positive for us.
Yes, sir.
So second data if I use, I'll get 1 by 14 plus 1 by 25.2 is 1 by F. So this you have to solve. Okay. It's a bit complicated. I mean,
Sir, that they are given minus 18 and plus 18. That U and V are minus 18 and plus 18, no, sir. So we can take it as F is equal, sir.
Minus or plus?
Minus 18, sir. V is plus 18. U is minus 18, sir.
Okay. So that became me.
Yes, sir.
Yes, yeah.
No, sir. Like that one, we can take it like
Right.
we can use the relation F is equal to V by 2, sir. F is equal to V by 2, and we can put that 18. So F we will get 9 centimeters. So like that we can do.
Yeah. It was 9 centimeters. This is correct.
Sir, and they are asking us to find that upper one. You can see, no, sir, that y
Yeah.
distance they are asking us to find, sir.
At least you can find now because focal length is known. So 1/6 plus 1/v equal to 1/9. Okay, so
Yes, sir.
1/9 minus 1/6. Sorry. Just a minute. Yeah. So v is 1 by this one minus 1 by.
Sir? Sir?
Hold on. Let me finish this one. One by 9 minus 1/6. So this you can calculate, right?
Yes, sir.
Yeah. So from this I can find v.
Yes, sir. Something it would come like 5 by 1 by v is equal to 5 by 18 will come, sir.
This 9 and 6. So what is the LCM? 15.
18, sir.
Yeah, 18. So 2 minus 3. So v is minus 18.
Minus 18, sir. V is equal to minus 18.
Because u is minus 6. No, so that's than the focal length. Because focal length is 9. So it's within the focal length. So focal length holds, obviously the image will be virtual.
Okay, sir. Sir, I have one more doubt in assertion reason question, sir.
Okay.
Sir, assertion says a concave lens forms virtual image of extended real objects, and reason is concave lens is diverging lens in nature. So both assertion reason are true and reason is correct, no, sir.
Yeah.
Because like sir, that too, this thing alone I cannot understand, sir. It's telling concave lens forms virtual image of extended real objects. That one can you explain, sir?
See, this is extended real object only. Only this is a point object. Okay.
Yes, sir.
Extended 1D object. So similarly, I can have something like this. This is a 2D object. I can have something like this, a 3D object. Okay, but in the book we have only 1D object. Only this is there.
Yes, sir.
Okay, this one is going to be extended. Yeah. So for a concave lens, if the incident light is like this, after refraction go like this. So it's
Yes, sir.
Okay, for concave lens, sorry, convex lens, it's like this. This converging. Okay.
Okay, sir.
Yeah. So.
Sir, so it would be assertion and reason are true. Reason is correct explanation for assertion, sir.
Yeah.
Okay, sir. Sir, and a table one question that once if we find that focal length is 9 centimeter, if they are with that, if they ask to find any image distance, we could use that focal length and find the value, sir.
You're talking about this table?
Yes, sir. Like they have given one more thing, x also. So for finding that x also, we can use this focal length 9 centimeter and find the value, sir.
Lens, no. Once a lens is fixed, focal length is fixed.
Sir, okay, sir. Okay, sir.
One single lens.
Yes, sir.
Obviously, the same focal length is true for all the data.
Sir?
Same focal length is true for all the data.
Okay, sir.
Okay.
Okay, sir.
So,
sir.
I guess here the focal length is 9. So, greater than 9, the image will be positive. I mean, V will be positive. So, this is data.
Yes, sir.
Greater than 9. It's beyond the focal length, focal point. So, obviously, V is positive here. Only this, the first one, it's within the focal length. So, image is virtual and the Y is will be negative.
Okay, sir.
Minus 18. Okay.
Okay, sir. Yes, sir. Clear, sir.
Yeah. So, getting back to our list of topics, I think I'll go from the from a little bit in the middle because something I did in the class. Okay. So, refractive index. This is here. This is glass. Glass is called denser medium because the refractive index of glass is greater than 1 compared to air, or with respect to air. Denser medium means denser medium is refractive index of the medium. Then we call that, for example, glass with respect to air is greater than 1. That means the velocity of the speed of light in glass is less than the speed of light in air. So refractive index of glass with respect to air is also is actually greater than 1. So it's the ratio of the velocities. So the velocity which should come in the numerator is the velocity of the speed in air. Okay, so here it's we can call this second medium, and there's first medium. The second medium will come at the numerator, denominator. First medium will come at the numerator. So refractive index of air with respect to glass also you can define. This means that the light is traveling from this is air, this is glass. So refractive index of glass with respect to the light is traveling like this. But the light can also travel in the opposite direction. There's nothing stopping it. So light can also go this way. So from here we go away from the normal. Okay, so for this thing I'll use refractive index of air with respect to glass. So here this will be velocity. This will be less than 1. This will be velocity in the glass by velocity in air. So from this I get important result that refractive of glass with respect to air is 1 by the refractive index of air with respect to glass. Okay. In some sense here this refractive of that with references here. Here refractive of air with reference as glass. These two are reciprocals. Okay. So in denser medium, the light will go towards the normal. That you can understand from here also. This picture. What I wanted to say. This is denser. So yeah, this is the air which is rarer medium. Glass is denser. Denser, this is the velocity of speed of light is less here. So this thing, if it has to go straight, it will go like this. This incident light, if it has to go straight, it will go like this in this part. Okay, I'm not drawing properly. So instead of that, it's going towards the normal. That way, it take a shorter path because if I compare, it goes like this. Okay, so if I compare this path length, where it goes straight, compared to the actual refracted path, this path is shorter. The path will be shorter compared to this path. So here the velocity, speed of light in glass is reduced, so it will take a shorter path. Okay, so this path is shorter compared to this path. So when it goes towards the normal, the path taken with the light is shorter. So that way you can remember that when it enters a denser medium, the speed will go down because of the light will go towards the normal. Once it goes towards the normal, the path taken is shorter. Okay, so here again when it comes down, it will be opposite. This light instead of going straight like this, at this point there is a normal here, right? It will go towards the normal. So this is actual emergent ray. So this is the angle of emergence. Here in this case, it's same as I. This is a glass prism. Glass slab. So I and E are same. Okay, but it is less than. I mean, it's happening. I'm going to mistake here. It should be away from the normal. Yeah. Instead of going the straight path, you go away from the normal. So this is the emergent tone. Yeah, that's what I said. This refractive index of second medium with respect to first medium. So second will come in the denominator. So first will go in the numerator. Okay. So if it is glass means velocity of light in the air will be more, so it's greater than 1. So this is reflecting the first medium with respect to second. So first medium will go to the denominator. Water comes second will go to the numerator. So V2 by V1. So these two are reciprocals. Okay. So remember this result. So in the eye, human eye, you just have to know what are the different functions of this one. Crystalline lens, the convex lens. Pupil is the opening of the lens, because if the light is strong, more intense, you have to reduce the amount of light entering the eye. So that can be done just like a shutter, iris. So this closes the opening of the eye. So if the light is bright means the size of pupil will go down, will become small. If the light is dark means the pupil will open up, or it will, so the iris opening, pupil opening will open up, so iris will go down. So that is the job of iris. Depending on the intensity of light, if the light is bright, it will reduce the size of the pupil. And ciliary muscles is it will adjust the focal length of this convex lens by changing the curvature. Okay. For human eye, the V is fixed. V is the distance of the lens and the screen, which is the retina. So this distance is fixed. So V is fixed for an eye, human eye. So once V is fixed, when U is changing, focal length has to change, because 1 by U plus 1 by V equal to 1 by F, U with the negative sign. So since V is fixed, focal length has to change depending on the object distance. So optic nerves for carrying this image signal to the brain. So these different functionalities you should know for human eye. So this eye with the defect. So this is the N prime is the 25 centimeter point. Okay. So for this defective eye, which is hypermetropic eye, for 25 centimeters, object the image is forming beyond the retina. So to correct that, so for this eye, only object at this N, which is at beyond 25 centimeters, will form image at retina. But for a good eye, even N prime will form image at the retina, but which is not happening here. So this thing is getting converged far away. To make it converge to the retina, I have to use an additional convex lens, because convex lens will converge, right? So this will make it converge at the retina even for object placed at 25 centimeters, which is N prime. Okay, so this is so here I cannot see nearby objects. Okay. For this side, for a normal eye, if you have a parallel beam coming from faraway object, the image should form at the retina. But here it's not forming because it's defective eye, it's myopic eye. But if the object distance reduced to this point, then will form image at this point. So for this eye, you won't be able to see objects from this point to infinity. So to make this object, this parallel rays to form image at this retina, I have to diverge this rays. To do that, I have to introduce concave lens. So for getting myopic eye, I have to use concave lens. Okay, so this is a defect which the students have, like they cannot see the things on the board, but they can read letters from a book. So the board is like a distant object which they cannot see. So most of the students will have their lens as a concave lens. Okay, this is for older people. They cannot read nearby objects. Okay, so good eye, the near point is 25 centimeters, like greater than 25 centimeters they can see, and far point they can see up to infinity. So the range of their visibility is from 25 centimeters to infinity. This is for a good eye. But if the far point is less than infinity, like board is not visible, then you have to use a concave lens to correct this defect. Okay, and the person who cannot see nearby objects. Okay, so here he cannot see even 50 centimeters. Okay, for that he has to use a convex lens. Okay, but some people both the ranges, he cannot see even objects greater than 25 centimeters and also less than infinity. We should be greater. Okay, yeah, greater than 25 centimeters. So for this, we have to use bifocal lens. Because here both the ranges, the visibility is beyond 25 centimeters, it will be like 50 centimeters, and he cannot see infinite objects far away also. So for that, he has to use bifocal lens. Okay, so here the lower part will be for reading the book, which will be a convex lens, and the upper part will be for distant reading, that will be a concave lens. So this defect is called presbyopia. Myopia. So if we say the eye has got a near point of 50 centimeters, means this is the problem. Like the object at 50 centimeters he can see, okay, but not beyond less than that. So for that I have to, so the object within this 50 centimeters I have to correct it to make it to come at 25. Yeah. So this is a concave lens, and this is a convex lens. So in this convex, the middle part will be thick, and concave lens, the outer part will be thick. Okay, so here you can see as a rings here. And power of concave lens and convex lens, power is nothing but 1 by f, right? Power of a lens, convex lens, is 1 by focal length. So for convex lens, the focus on the right side, because this is the origin, this is the positive side. So for convex lens, the focal length is positive. But for concave lens, this light will go like this. Okay, so projected backwards. So the focal length on this side. So this is the focal length for concave lens, which is negative. So power also for concave lens, power is negative, and power for convex lens is positive. So the specs which the students wear, the power will be negative. Because it's a concave lens. Okay, and unit for power is diopter when the focal length is measured in meters. Okay, if you put in centimeters, you'll get the wrong answer. So make sure to, if you want to get the power, you have to put the focal length in meters to get the power in this unit, diopter. And the focal power of this concave lens is negative. Magnification of lens and mirror, and magnification. Okay, the basic thing is image size by the object size. Okay, and it should be negative for inverted image. So for convex lens, so the y-axis positive is upwards, positive y. Okay, so if the object is like this, h, the image, if it is radial image, will be like this, h prime. So obviously h prime is negative, so I don't know put a negative sign here. So this will give me the negative answer. But here u is negative and v is positive. So magnitude is v by u. I put a negative sign here to make it positive. Sorry. Here I have to get a negative sign only, so I just put v by u. There is no, because for this particular situation, u is negative, so I don't have to put any, so it's plus 1. There is no sign here. But for mirror, it will be, I have to put a negative sign. In the case of mirror, it's always h prime by h. But if we take a concave mirror and have an object like this, so the image will be real and inverted. So, since it's inverted, there should be magnitude should be negative, and same convention as this is positive for y-axis. H prime is negative, so h is positive. I don't have to put any sign here. But magnification again v by u here. But here both v and u are negative. U is negative, and v is also negative. So it will be positive. So to get the negative sign, since it's an inverted image, I have to introduce negative sign here. To get the negative sign for inverted image. Okay. So magnification negative is inverted image, and magnification greater than 1 means enlarged image. Image is greater than the object size. And magnification fraction meaning less than 1, but is greater than 0. Okay. This is diminished image. Okay. And another thing is between 0 and -1. So it's a diminished but inverted. Diminished and inverted. This is erect. Magnification greater than 1 is enlarged and erect. Okay. And magnification less than -1 is enlarged and inverted. Okay, plus and minus says whether it's erect or inverted. For inverted, it's a negative sign. And whether it's fraction of greater than 1, that will say it's diminished or enlarged. Okay. The meeting will get over in 5 minutes. So after that, you have to rejoin. So these are the topics I can go backwards. I started from here, right? Yeah. Concave lens. Yeah, this is same for both concave lens. You have to move the object from infinity to the pole, and you have to see how the image will change. Same for convex lens also. It is there in book in tabular form.
Sir,
Yeah.
I have a doubt. You said like if the magnification is greater than -1 and less than 0 means the image formed is diminished and what's erect or inverted?
Inverted. Negative sign is inverted. Okay. Fraction is diminished. Where is between -1 and
So
0.
the image, if the magnification is greater than -1 and less than 0 means it's diminished and inverted.
Yeah.
Yeah. Okay, sir.
So this is the number line, no? 0, 1, -1. So magnification in this range, okay, it's diminished because it's fraction.
Okay, sir.
Okay, this is erect because it's positive, right? This is inverted.
Okay.
So here it is erect and enlarged. Here it is inverted and enlarged. Okay, so negative sign is inverted. Okay, whether it's diminished or enlarged is a fraction, doesn't decide. If it is a fraction means diminished image.
Okay, sir.
So if the magnification is exactly 0, then what it will be?
Magnification
Sir?
0 does not make sense. No, that means no, here, hold on. Magnification is image size by object size. Okay, so this 0 means then in the okay, why do you want to go to such things? Okay, if you take a convex lens, parallel beam will make it focus. No, so whatever is the object here, it will be a point object here. So in that case, magnification is 0 only. Image size is 0, object is of finite size. So here magnification is 0. Okay, so when you bring it closer, here say center of curvature, and this is the focal point. So here V is getting decreased, right? Sorry, U is getting decreased. and V will increase. So magnification will increase. Okay.
Sir, so
Okay,
you're
sir.
saying that magnification will not be equal to 0.
It can. So what I'm saying is, if we take a parallel beam from large distance, we'll form a point image at the focus. Right. So size of the point object is 0, right? So H prime is 0 for point object. This is like a limiting case, just I mean, don't bother too much about it.
Okay, sir.
Okay, sir.
Yeah. So who raised that?
Yeah.
Yeah.
Sir, when do we say that the size of the image is equal to the size of the object, sir?
When V equal to U. That you can
Okay,
figure
sir.
out, no?
Can there be any possibility where the V will be equal to U, sir?
Hold on. So let me take a lens case. Okay. So for lens 1 by U plus 1 by V equal to 1 by F is actually minus 1 by U. Okay. So you're saying, okay. So what you're actually saying is minus U equal to V, right? Because U is negative for lens and V is positive. So minus 2 should be equal to U. So in that case, this will become 2 by V equal to 1 by F. So V is 2F. That is at the center. So this is the focal point. This is the center of curvature. So if the object is here, then the image will form at the same C here. Okay, of the same size.
Okay, sir.
So U is 2F or minus 2F. V is plus 2F. In that case, both image and object size are same, and magnification is 1.
Sir, you said when V is equal to U, then the image and the object size is the same, sir.
See, in this case,
So in only concave mirror only, it will be equal, no, sir. In convex, always the V will be plus, no, sir.
no. See, the object distance is minus U, not plus U. Okay, so I can make minus U equal to V. See, for this particular situation, U is saying minus 10. That focal length is say 5 centimeters. Take a concrete example. I'm placing this object at this point. So U is minus 10. For this, V will become plus 10. Because this is the formula.
Yes, sir.
Okay. So
Okay, sir.
positive quantities. Think in terms of minus U, because here U is negative. So think in terms of minus U. Okay.
Okay. So, but in concave lens, V will all be minus, no, sir.
Yeah.
Most of the times V will also be minus.
To
So
get the formula,
minus V equal to V.
yeah, U is always negative because U is on the left side, irrespective of whether it's concave or convex. To give the concave lens, okay, this is my positive direction. Object level is placed here. I don't want to complicate it. So U is negative. Okay, but here after it comes here, it will diverge, no? The light. So I have to project it backwards. So the
Okay.
image will form here. So V is also negative.
Yes, sir.
Focal
So
length is also
most
negative
probably
because
yes, sir. So most probably in concave lens or mirror only, the V and U will be equal, no, sir.
here if you put see the formula is same for concave and convex. Okay, so here if you here yeah, both are negative, so it's not possible. Here minus U equal to minus V. Here V is negative. Okay, so this means that U equal to V. So if you put U equal to V, then